Hello. In this content, we are trying to learn how the integration of different Landsat data is done. As you know, it has already been nearly 50 years when the first Landsat satellite was launched. Each Landsat has the different instruments, sometimes improved, sometimes new. There is a tutorial in the developers.google.com in the guide section, which in particular shows us the idea on the harmonization of different Landsat instruments or sensors. That is Landsat ETM plus surface reflectance with Landsat OLI surface reflectance and with TM or thematic mapper as well. So to note, Landsat it has OLI, that is the operational land imager. Landsat 7 has the enhanced thematic mapper plus, and Landsat 5 has the thematic mapper. So harmonizing is possible through the linear transformation of ETM plus OLI spectral space. This is based on the literature available. So to begin with, we have the dictionary here with the variable named coefficients, which has slopes and intercepts. There are the intercepts already based on the literature available for different bands. And the y-intercept here is multiplied by 10,000 to match the scaling. So this is also the way to make a dictionary. So, and after that, we select the band names and rename the bands according to the wavelength. So this is for OLI and this is for ETM. These are the two functions we use later. And here we have the linear function. We multiply it by coefficients here, coefficients, and add the intercepts. So here we have coefficients dot slopes, and here we are adding by coefficients dot intercepts. And also we want to select the pixel keyword that is attached for other purpose of masking. And here we have the function to mask the cloud and shadow. The idea is to select both cloud and shadow pixels and hide them. So this function is we see most of the time, and this is very popular. You need to understand them in very detail. But here we are skipping it. And we calculate NBR, that is normalized point ratio. It is found to be with greater signal to noise ratio with regard to forest disturbance. So here image dot normalized difference. This is the function already available in ArcEngine, and this can be used for finding NDVI or other similar other indices. And we finally have the function here. Here are the two functions that applies previously defined functions. We rename the bands, and we apply the mask, and we calculate NPR. Similar is the work of two functions. And the second function, we convert ETM to OLI. So here is the linear function applied. Finally, we have the point here. It can be any point. And this is for our finding the pixel best in this point. And we have the different data sets here. And then after, these are the different Landsat data sets. This is Landsat 8, 7, and 5. So we filtered the different data sets based on the point, based on the calendar range. Here exactly the dot calendar range is used. We are not working with the dates, but with the day of the year. And then after, we are also filtering it by cloud cover and other metadata. Here we are copying from the tutorial, so we are leaving as it is. So after that, we prepare the function to get all your, and then after we merge them all. So we are merging them all. And We merge them all, and after that we have the ready to prepare it for the time series. We are calculating median of all the pixel values. And finally, by ui.chart.feature.groups, we get the chart. There's a system time that is to in the x-axis, and we have the NBR as the y variable, or x variable, and that is also set to satellite with distinct color. That is to have three different satellites. And there are other options are just for the visualization purposes for the chart. There are set options, there are series names, and there's other options only. And finally, we can print that one out. And from the time series, annual median values can also be used. So images are grouped by year here. It is the grouping of the year, and years are subset and made distinct to represent the year. And after we have the years are matched with the year collection, and complete collection is saved, which matches. And then after we have the feature collections converted to image collection here. And here the median reduction is applied. And finally, the chart is prepared, which displays the median NBR values from the sets of intra and. So there are so many things going on. I may have skipped most of the things, but the general idea is to select the median values, to select the years and combine all the median values, and finally produce a chart. So when we run this, now we get the chart as shown in the tutorial. This tutorial in particular, if we check the guide, is filled with so many functions, and we get to know how functions are applied. And also, this type of applications are likely to be applied with Landsat 8 and Landsat 9 in future, I believe. And it is here to have some. It is good to have some general understanding of how the different instruments are harmonized. So I hope this was helpful. If anyone was watching till the end, thank you. Any comments are welcomed. Thank you.